welcome to True Projects. In this video, we are going to explain about the project entitled as End-to-End Architecture for English Reading and Writing Content Assessment based on Prompt Learning. So before getting into the video, let me give you the brief description about the project. The title refers to an undefined system that automatically evaluates English reading and writing content without separate processing stages. It uses prompt learning, where carefully designed prompts guide a language model to understand tasks such as comprehension, coherence, grammar, and relevance. This approach improves assessment accuracy by leveraging contextual understanding within a single model framework. Coming to the abstract explains the importance of accurately assessing English reading and writing skills and highlights the limitation of existing assessment methods. Traditional machine learning and deep learning models often depend on manual design features which restrict their ability to understand complex language semantics. To address this, the study proposes an end-to-end assessment system based on prompt learning combined with multi-scale attenuation mechanisms. By integrating CNNs, LSTM, and attenuation techniques, the model captures both local and global linguistic features and directly predicts assessment scores. Experiment results on standard dataset shows that this approach achieves higher accuracy and robustness than convolutional models. Coming to the existing system relies mainly on handcrafted linguistic features such as grammar rules, word count, and synthetic patterns for assessing English reading and writing content. Although some deep learning models are used, they often separate feature extraction and evaluation stages, increasing system complexity. These methods struggle to capture deep semantic meaning and long range dependencies in text, especially in long or diverse essays. As a result, their performance decreases when applied to different datasets or writing styles, limiting scalability and generalization. Coming to the proposed system or base paper work, the proposed system introduced a fully end-to-end architecture that eliminates manual feature engineering by using prompt learning and multi-scale attenuation. Prompt learning helps guide the model to extract meaningful semantic representations from input text automatically. CNN layers capture local textual patterns, while BiLSTM and multi-scale attenuation mechanism models long range and global dependencies. Finally, a fully connected layer predicts assessment scores. This integrated approach improves accuracy, efficiency, and robustness across multiple benchmark datasets compared to traditional and attenuation-based model. Coming to the novelty or extension or enhancement or improvement. First, we have hybrid attenuation based architecture. This extension introduces a hybrid deep learning model that combines self attenuation with BiLSTM and BiGRU networks. Self attenuation allows the model to identify and focuses on the most important words and phrases in a text, regardless of their position. By doing so, it improves contextual understanding and reduces the limitations of purely sequential models that process text word by word. Next, we have reduced computational complexity. BiLSTM networks are powerful but computationally expensive due to their complex gate structures and large number of parameters. To reduce this cost, BiGRU is integrated into the architecture since GRU uses fewer gates and simpler operations. This combination lowers computational requirements, shorten training time, and maintains strong contextual learning capability. Next, efficient feature encoding. In this hybrid design, BiLSTM is responsible for capturing rich and complex contextual information from both forward and backward directions of the text. BiGRU then refines and compresses these features using fewer layers and parameters. This staged encoding strategies ensures effective feature learning while avoiding overfitting and unnecessary computational overhead. Next, we have Improved prediction accuracy. GRU's simpler structure helps the model focuses on essential patterns and reduces the influence of irrelevant or noisy features. When combined with self-attenuation and bi-LSTM, the model benefits from both deep contextual understanding and selective focuses on important information. This leads to better feature representation and improved accuracy in assessing English reading and writing content. Next, we have faster training and scalability. By replacing part of the heavy LSTM processing with lighter GRU units, the extended model converts faster duration time. Thus improves scalability and makes the system more suitable for large-scale educational platforms. As a result, the architecture supports efficient real-time or near real-time assessment without sacrificing performance. Along with this, as an extension, the Flask framework is used to develop a user-friendly interface that allows users to provide input data for prediction. The inputs are pre-processed and passed to the trained model based on the data set. The predicted results are then displayed through a web interface, making the system easy to access and use. Coming to the dataset, the ASAP 2.0 dataset is a comprehensive English writing dataset created for automated essay scorings and writing quality evaluation. It consists of 24,278 student written essays produced by students from grade 6, 8, 9, and 10 during standardized assessment. The essays are score based, required students to read given passages and respond by integrating information and augmentations from those scores, which makes the dataset suitable for evaluating both reading comprehension and writing ability. Each essay is scored by human raters and includes additional metadata such as grade levels, English learners' status, and socio-economic indicators. Due to its large size, diverse prompts, and real educational context, the dataset is widely used to train a benchmark natural language processing models for holistic and robust writing assessment. Coming to the workflow, firstly, we have input text collection. The workflow begins with collecting English reading or writing content from users. This input may include essays, passages, or written response submitted through the system interface. Next, text pre-processing. The collected text is cleaned and standardized by removing noise such as extra spaces, special characteristics, or irrelevant symbols. Tokenization, lowercasing, and normalizations are applied to prepare the text from model pre-processing. Next, prompt learning integration. Prompt learning is applied to guide the model by embedding task-specific instructions into the input text. This helps the model understand the assessment objective and extract more meaningful semantic representations. Next, automatic feature extraction. The system automatically extracts linguistic and semantic features using deep learning models instead of manual feature engineering. This allows the model to learn patterns directly from the data. Next, multi-scale attenuation mechanism. The multi-scale attenuation model focuses on important words, phrases, and sentence level patterns at different gradualities. It captures both local and global dependencies to improve content understanding. Next, sequence encoding. Encoded representation of the text are generated using sequence models such as BiLSTM and BiGRU. These models analyze contextual information from both forward and backward directions. Next, feature aggregation. Outputs from different encoding and attenuation layers are combined into a unified feature representation. This step ensures that all relevant linguistic information is consolidated before prediction. Next, prediction layer. A fully connected layer processes the aggregated features and generates the final assessment score or classification output based on the learned patterns. Next, model training and optimization. The model is trained using benchmark data sets and optimized through loss minimalization and parameter tuning. Optimization techniques improve accuracy, stability, and generalization. Next, Performance evaluation. The trained model is evaluated using metrics such as accuracy, precision, recall, and F score to validate its effectiveness and robustness across data set. Next, final assessment output. The system produces the final evaluation results, which indicates the prediction score or assessment feedback for the given input text. Coming to the front end is developed using the Flask framework, providing a simpler and interactive web interface. User registration and login functionalities are implemented with SQLite database support. Authenticated users submit their English text through the front end interface for assessment. The submitted text is automatically pre-processed using the same steps applied during model training to ensure consistency. The trained deep learning model is loaded and used to generate predictions based on processed input text. The final assessment result is displayed on the front end, allowing users to view their evaluation output clearly and instantly. Coming to the requirements, we have both hardware requirements and software requirements. Hardware requirements consisting of operating systems Windows only, processor i5 and above, RAM 8 GB and above, hard disk 25 GB and above. Software requirements consisting of application framework is Python 3.10.9, primary language is Python, front-end framework is Flask, backend is Jupyter Notebook, database is SQLite 3, technologies which we use to build the front-end are HTML, CSS, JavaScript and Bootstrap 4. To execute the project, first we need to open the code folder which contains the project source code files. This folder is a complete package of your project's code base containing everything needed to develop, test, and deploy your application or model. Static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. Templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represents different pages of the website. App.py file. This .py file contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. These are the model files which contains algorithm information which will be loaded into the project code during the runtime. .ipynb file. This is a Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute the code in individual cells, making it a popular choice for data science. Signup.db file. This is a database file used to store the user information. Now, coming to the execution of the project, first, you need to copy the path of the code folder from the address bar of the file explorer. Then, open command prompt. Use the command cd followed by a space and then paste the copied path. This command is used to change the current directory to the code folder's path. Now, compile the app.py file using the command python space app.py in the command prompt. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address with the port number of 5000. Copy the local link provided by the framework and paste it into any web browser. I prefer Chrome. The home page of the project should now be displayed in the browser. This is a front end built using Flask framework. In this page, we have home button, login button, and get started button. Firstly, click on get started button so that create account will be opened, where we need to enter the details and create an account for user authentication like username, full name, mail ID, mobile number, and a strong password. Then click on create an account so that all the given details are stored in signup.db and login.html will be opened, where you need to access the application by entering username and password. Then click on sign in so that the prediction page has been displayed. In this page, we have assessment prediction button, graphs button, notebook button and logout button. Firstly, click on assessment prediction button so that the automated English essay scoring form will be opened, where we need to enter the essay, then click on predict score so that the given essay is pre-processed and the output is displayed as assessment score is of 1 out of 6. Here we have significant improvement required. Why? Because we got the score of 1 out of 6. The targeted improvement recommendations are given like grammar fundamentals, sentence structure, basic vocabulary, essay organization, and writing practice. We have here new assessment button and view analytics button. When you click on new assessment button, again the form will be opened where you can enter the essay and check for the prediction score. Now click on graphs button so that the graphical representation of the project will be displayed. Let us check one by one. First we have dataset scores class distribution graph. The bar chart illustrates the number of samples in each dataset scores class ranging from 1 to 6. Class 3 has the highest number of samples, followed by class 2 and 4, showing a strong concentration in the mid-range scores. Class 1, 5 and especially 6 have significantly fewer samples, indicating an imbalanced distribution towards the extremes. Next, we have confusion matrix graph. The confusion matrix shows the classification performance of the CNNs with multiscale attenuation and GRU across 6 classes. High values along the diagonal indicating strong correct predictions, especially for class 2, 3 and 4. Some misclassifications occur between neighboring classes such as class 3 being predicted as class 4 and class 5. Overall, the model performs well on mid-range classes but shows weaker performance on extreme classes. Next, we have accuracy comparison of algorithms graph. The bar chart compares the accuracy of 3 different algorithms, the existing baseline, the proposed multiscale attenuation model, and the extension with attention plus GRU. The existing baseline achieves a relatively low accuracy of about 64.03%, while introducing multiscale attenuation significantly improves performance to 91.93%. The highest accuracy, 92.24%, is obtained by the extended attenuation plus GRU model, indicating that combining attenuation mechanisms with GRU further enhance classification performance. And next we have precision graph. The bar chart illustrates the precision performance of 3 algorithms, the existing baseline, the proposed multiscale attenuation model, and the extended attenuation with GRU approach. The existing baseline shows relatively low precision at 45.77%, indicating a higher rate of false positive. Introducing multi-scale attenuation significantly improves precision to 86.09%, while the extension with attenuation plus GRU achieves the highest precision of 91.17%, demonstrating more accurate and reliable predictions. Next, we have recall comparison graph. The bar chart compares the recall performance of the existing baseline, the proposed multiscale attenuation model, and the extended attenuation with GRU method. The existing baseline achieves a recall of 51.66%, indicating that many relevant instances are missed. The proposed multiscale attenuation model significantly improves recall to 89.09%, while the attenuation plus GRU extension attains the highest recall of 93.27%, showing its superior ability to correctly identify most true instincts. Next, we have F-score graph. The bar chart presents the F-score comparison among the existing baseline, the proposed multiscale attenuation model, and the extended attenuation with GRU approach. The existing baseline records a low F-score of 46.72%, reflecting weaker overall classification balance. The proposed multiscale attenuation model shows a substantial improvement with an F-score of 87.34%, while the attenuation plus GRU extension achieves the highest F-score of 92.15%, indicating the best balance between precision and recall. and then click on log out. So finally, this project presents an end-to-end architecture for English reading and writing content assessment that effectively eliminates manual feature engineering through prompt learning. By integrating deep learning models with multi-scale and hybrid attenuation mechanisms, the system captures both local and global linguistic features with high accuracy. Experimental results demonstrate improved performance, efficiency, and scalability compared to traditional methods. Overall, the proposed approach provides a robust and practical solution for automated language assessment in educational applications. So, this is all about your project. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.